Section 4.9 talks about rank, nullity, and the fundamental matrix space. We're going to focus on rank and nullity for the most part in this case. Let me start with some definitions. Let's make sense out of those. Theorem 4.9.1 says the row space and the column space of a matrix have the same dimension. Let me remind you, if we put those in reduced echelon form, if I only have, doesn't matter what's there. If I look at the pivots, then in this case, if these are the only pivots, I would know that the row space, there are 2 rows, and the column space, there are 2 columns. The rest is going to pretty much represent the null space. So when they say the row space and the column space of a matrix have the same dimensions, that means yes, you know, if you have 2 of them, 2 rows, then it's going to be 2 columns. They're not talking about these vectors belong to which R. They're just talking about the numbers of those, the size of those. The common dimension of a row space and a column space of a matrix is called a rank. So the rank of A is normally dependent on the number of pivots. When you reduce the matrix to echelon form or reduced to echelon form. So, and we label it as rank of A. The dimension of the null space. Now remember what the null space is. So the null, they call it nullity of A or null of A. Remember, whatever I have left overs, right? Those should equal the number of free variables. Meanings, whatever you're allowed to have a parametric equation. Between the two, that should add up to a total number of columns in the matrix, not the rows. So I start the problem by looking at, I start the matrix by looking at the columns. I will reduce it. And as many pivots as I have, that will be the rank of A. And whatever free variables I have, I'm going to let you know, x3 be t, x4 be s, or you know, it's free. Those, the remaining parts that continue the number of columns for x, you know, x sub 3, 4, all the way to n, those will be, the number of these vectors will be the nullity of A, or the dimensions of the null of A. And of course, this is obvious now. Let me again make sure. Let's say I have the following matrix. No, this is too obvious. Let's say again, this is just for, I shouldn't really do this, but I want to make sure I understand this. So if I'm looking at this problem, I notice we have 2 pivots. So I'd say the rank of A in this case is 2. Now what does that mean? The remaining 3 would be 3. They both must add up to total number of variables or columns in check. And of course, if the rank is 2, that means you have 2 column spaces and 2 row spaces, 2 column vectors and 2 row vectors. And last, if I have an n by n, remember how this works. That means I have n unknowns. If A is an n by n, then the rank of A equals the number of leading variables in the general solution. Right? And the nullity will be whatever is left over. The parameter, that's when you say x3, for example, is free. Or you say x3 equal t, whatever you want to call it. Whatever you allow the variables to be x3, x4, x5, then guess what? That will be the nullity. And we always set ax equals 0 to figure those out. Now I'm going to demonstrate by a few examples. This is not a long section, but it's very important for what's to come. Find the rank and nullity of A by reducing it. Now, you'll notice later on we're going to start getting those reduced, but let's reduce it. So if I'm looking at this matrix A, if I take twice row 1 plus row 3 and row 3, now you might be asking, how come they're not setting that equal to 0? Well, they are, but since that never changes, they just work with this and assume there's 0, 0, 0 on the right. Now, they row reduce it all the way. They use reduced to echelon form. We don't. We just row reduce it. So 2, that's a 0. That's a negative 1. 2, that's a negative 4. Plus 1 is negative 3. That's a 2, 1, 3. Excuse me. And okay, now if I take, let's see. If I take negative row 2 plus row 3 and row 3, and if I take row 3 plus row 4 and row 4, not using nor changing, using but not changing. If I multiply this by a negative and add it to that, that would be 0, 0, 0, 0, 0. And if I take those two rows and I add them, I'll get 0, 0, 0, 1, negative 1, if I'm not mistaken. And now I could, of course, take row 3, switch it with row 4, and might as well, just to make the author happy, multiply row 2 by negative 2. But again, you don't have to do that. We're not after finding those, we're just after identifying those. And of course, on a test or quiz, that last step is unnecessary. Well, let's see how this works. This is x1, x2, x3, x4, x5. So, n is 5. Between the null and the rank, they should add up to 5. Well, let's see. 1, 2, 3. So, when they say what is the rank of A is 3. And we know that x3 is free and x5 is free. So that's kind of when you say, I decided to just call them x3, x5, in the book they say, oh, let x5 equal t, x3 equal s, or whatever you want. Nullity of A will be 2. So both of those must add up to 5. The idea is really simple. Don't let the theorems throw you off. Now, how do you find them? We know how to do that. You find everything in terms of x3 and x5, just like we did in the 4, 8, and 4, 6. Here's another problem. If I look at B, and I'm trying to figure out how this works. Now, again, I normally wouldn't go for a 5 by 5 or a 6 by 6 or 7 by 7, but let's assume we're going to work this out and see how, let's work this out and see how that works. So let's take a few steps. 3 row 1 plus row 3 and row 3. Let's take row 3 plus row 4 and row 4. And let's take negative 2 row 1 plus row 5 and row 5. Now before we start, the most I can get out of this is 4. I notice we have more rows than needed. Well, for sure, at least one is going to zero out. Now let's see how would this look. I'm trying to work slower so you could see this better. And I'm writing more legitimately because students have asked me to do that. Not a problem, I apologize. if I take 3 times row 1, 3 plus 3 is 0, 9 plus 0 is 9, 3 plus 6 is 9, and 9 minus 1 is 8. Now, if I make a mistake, we want the idea. The chances of making an error is pretty high. If you add those two, I'll get a 0, 4, 4, and a 0. And if I take negative 2 times row 1, negative 2 plus 2 is 0, negative 6 plus 0 is negative 6, negative 2 minus 4 is negative 6, and negative 6 minus 2 is negative 8. Now, if I take, let's see, if I take negative 9 row 2 plus row 3 and row 3, if I take negative 4 row 2 plus row 4 and row 4, and if I take 6 row 2 plus row 5 and row 5, what would happen? So 0, negative 9 plus, negative 9 plus, and 0 plus 8 is 8. Very good. If I multiply by negative 4, see, this first one is 0 for sure. 1, 2, 3, 4, 5. Okay, good. If I multiply by negative 4 plus 4 is 0, negative 4 plus 4 is 0, and 0 plus 0 is 0. And if I multiply it by 6, 0, 6 minus 6 is 0, and 0 minus 8 is negative 8. Now, if I just take row 3, add it to row 5, put the result in row 5, pretty much I'm done. So the work is not that tense. Oh, and take row 3 divided by 8, put it back in row 3. You really don't have to. You could leave it as 8. It doesn't matter. Well, what do we have? Let me go back and use this analogy. x1, x2, x3, and x4. I have a pivot there, and I have a pivot there, and I have a pivot there. That means the rank of A is 3. Not only that, I want to find the nullity, and I want to specify, because that's what we're going to find in chapter 5, 5.1 and 5.2. I want to make sure that you understand x3 is free, and that's the only one. That makes that a 1. So that's pretty much how it works. You're going to find the null space will consist of just one vector. In the previous problem, the null space will consist of 2 vectors in terms of x3 and x5. And we'll talk about those when I get to the next section, putting everything together. When I get to the next 2 sections, we're only covering 5.1, 5.2. 5.3, well, we'll talk about it when we get there. All right, here's another problem. Let's look at this and make sure we get this. Again, the idea here is to concentrate on the theory, not the busy work. Here's A. They row reduced it, and I'm going to give you something like that on the test. The matrix R is reduced to reduce row echelon form. A. By inspection, find the rank and nullity. Well, let's see. If in part A, I want to find the rank of A and the nullity. Let's see. x1, x2, this never gets old, people. 1, 2. That's 2. And we have 1 free variables, namely x3, that's 1. B. Confirm that the rank and the nullity satisfy formula A. I'm not going to ask for formula A, but you should know that there are 3 variables n equal 3. And if you take the rank of A plus the nullity of A, what does that equal? Well, that's 2 plus 1, which is 3, and they have to match. They always have to match. And if I look at C, find the number of leading variables and the number of parameters in the general solution when you solve this. Well, we have two leading variables. And in case you're wondering, you have to list them, namely x1 and x2. And we have one parameter. That is when you say let x3 equal t, or the way I've been doing it, we're gonna say let x3 be free, and find the null space in terms of that one variable. Again, we're gonna do that in most of chapter 5152 mainly. The same thing happens again. So if I want to take this, I'm going to take x1, x2, x4. So A, the rank of A would be 3, and the nullity of A would be 1. They must add up to the number of variables, which is 4. And if I take the rank and add the nullity to that, that should equal 3 plus 1, which is the 4. That's B. And C, if I really want to look at the leading variables, we have 3 of them. 1, 2, 3. So we have 3 leading variables. You don't have to name them, but I want to name them x1, x2, x4. And in the next section, we're going to find the null space of every single one of those. We're going to focus on the null space more than anything. We have one parameter. And that is, you're going to say something like let x3 equal t, or simply x3 is free. I've been using that analogy, so that's fine. All right. One more to go. If I'm looking at an m by n, so this is something that we're going to do all the time. M by n, that is m of those, and n of those, right? So we have n variables, x sub 1, x sub 2, x sub 3, all the way to x sub n. They're asking, what is the largest possible value for its rank? We're talking about matrix A. If A is an m by n, what is the largest possible value for the rank of A? The largest value for the rank of A would be n if the number of rows are bigger than or equal to n, right? And the largest value for the rank of A would be m if n is, well, let's go the other way. Let's keep it the same. If n is bigger than m. So think about it this way. If I have 5 unknowns and I have 6 equations, the largest that could happen, I could have 5 pivots, and that would be this case. But if I have 5 unknowns and I only have 3 equations, the most I can get will be 3, assuming that you get 3 pivots, of course, assuming that's the case. And of course, the nullity, the smallest possible nullity, that also has 2 conditions. The first case, and think about it, if I have 5 and I have 7, well, the number of pivots would be at most 5, so this way, if m is bigger than n, then that would be 0, right? If I have 5 by 7 and you get 5 pivots, that means n is 5, and therefore there's no room left for the nullity. But if I have so this is like having 7 by 5. But if I have 5 by 7, for example, I have 5 equations and 7 unknowns. Obviously, I'm going to have 7 minus 2. So if m is less than n, I'm going to have, let me see how to put it, n minus m, 7 minus 2. If that happened to be m. When you add those two, you should get the number of columns or variables, the number of pivots available. A bit confusing, but once we do it in practice, you'll see it's straightforward. And that's pretty much it.